Centripetal acceleration is produced in the body because of centripetal force acting on it. What do you mean by this banking of roads? The contribution of friction can be reduced by the banking of roads. It's a force experienced by the body when it moves in a circular path, and it is also called as pseudo force. Hello everyone, I am Nishma Ranjamma, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome back to the last session in a Chapter 5, Laws of Motion. That is the 5th session where we will be studying about centripetal force, centrifugal force, and what you mean by banking of roads. To begin with, let us first try to understand what do you mean by centripetal force. In circular motion, we have discussed in a previous sessions about circular motion. What do you mean by uniform circular motion? If an object or if a body is moving in a circular path with the uniform velocity, then we call it as a body is in a uniform circular motion. Then what is centripetal force? For example, consider a circle. Consider a circle. This is the center of the circle. Consider a circle. This is the center of the circle. An object, a body is moving in the circular path. A body is moving in the circular path. The direction changes continuously. The direction of the object changes continuously. If there is change in the direction, that is only because of the external force that is acting on the body. There is change in the direction in the circular path of the object, that is only because of the external forces acting on the body. Then what kind of external force it is? For an uniform circular motion, the external force must act at every point of path in the direction along the radius towards the center of the circular path. Towards the center of the circular path. If that is the case, then we need a centripetal force. The centripetal force keeps the object in a circular path. We need the centripetal force. Centripetal force is that external force that keeps the object to move in the circular path. That is called as centripetal force. When we say there is a presence of centripetal force acting on the object, that means there is a centripetal acceleration produced in the body, centripetal acceleration produced in the body, which is acting along the radius towards the center of the circle, which is due to centripetal force. Centripetal acceleration is produced in the body due to centripetal force acting on the object. Then what is that centripetal acceleration given as? Centripetal acceleration acting on the body which is moving in the circular path is equal to V square by R. V square by R. Then what is your force? Force is given by F is equal to MA. Then it is equal to M into V square by your acceleration in the circular path is V square by R. So your force, your centripetal force FC. So your centripetal force FC will be equal to mv square by R. mv square by R. You can see here the centripetal force is equal to mass into centripetal acceleration, that is mv square by R. This is your centripetal force. This is your centripetal force. In case of angular velocity, you have m omega square by R. M omega square by R. Centripetal force is the force that is required, the external force required to keep an object in a circular path with uniform velocity is known as centripetal force. It is the force, that external force required to keep this object in the circular path, and centripetal force is given by mv square by R. In case of angular velocity, you have m omega square by R. Centripetal acceleration is produced in the body because of centripetal force acting on it. The centripetal acceleration is produced in the body if centripetal force is acting on it. This centripetal force is called as real force. It is called as real force. If you consider the giant wheel, you can consider a giant wheel. It is moving in a each body is moving in a circular path with uniform speed. Consider you have a string tied with a stone at one end, and one end I am holding it with my hand. So if a stone is rotated in a circle with one end of the string held in my hand, the tension in the string will provide the necessary centripetal force required for its orbit. Consider the artificial satellite moving around the earth. So the centripetal, the necessary required centripetal force is given by the gravitational force of the earth. Centripetal force is provided by the gravitational force of the earth. Like this, we have many such examples, like a stone rotated around a circle or artificial satellite moving around the earth, etc. So if you consider a circle, in a circle, object is moving. This is the center of the circle. Object is moving with a uniform speed. At each position, the direction of the object changes continuously. Change in the direction is present due to the external force acting on the object. This change in direction is produced due to the external force acting on the object. So for a uniform circular motion, an external force should act at every point in the path along the radius towards the center, Such external force is called as centripetal force, which is the real force, which is the force required to keep this object to orbit, to rotate in the circular path. Then what is centrifugal force? It is an apparent force. It is a force experienced by a body when it moves in a circular path. It's a force experienced by the body when it moves in a circular path, and it is also called as pseudo force. It doesn't have a physical origin. That's why it is also called as pseudo force. What is the centrifugal force? Centrifugal force is equal to, it is same as centripetal force, mv square by r. That is equal to, if it is angular velocity, then it is m omega square by r. Centrifugal force, it pushes the object away from its axis. It will push the object away from its axis or axis of rotation. It is acting away from the center. It is acting away from the center or axis of rotation. Whereas centripetal force, it acts towards the center. This force is responsible for the object to move in a circular path, whereas centrifugal force, it acts away from the center or axis of rotation. If for a body moving in a circular path, circular motion, that means with uniform speed, because of inertia of direction. There is inertia of direction, because of which the force appears to act on the body. In the direction away from the center or axis of rotation. The centrifugal force, it pushes the object away from the center or axis of rotation. Centripetal force is similar to centripetal force. F is equal to mv square by r, but it is an apparent force. It doesn't have a physical origin, and it's also called as pseudo force. Consider a person moving in a vehicle. He feel an outward force acting. When you take a circular turn. This is not the real force. It is nothing but the centrifugal force that a person is experiencing. It is not a real force. That is due to the inertia. Of the body to remain in the earlier state of motion. It is the centrifugal force experienced by the person. That outward force is nothing but the centrifugal force. It is not the real force. It's the centrifugal force, that is due to why he is experiencing outward force, because of inertia of the body to remain in the early state of rest. We have studied about inertia in our previous session. Please go through what you mean by inertia. So this is all about centrifugal force, a force that acts on a body, that appears to act on a body in a direction away from the center or axis of rotation. F is equal to mv square, Fc is equal to mv square by r. Next we have banking of roads. Where we will study derive the expression for maximum velocity for an automobile on a level circular road. I have to derive an expression for maximum speed of car in a level circular road. I need to derive expression for safe speed of car which is taking a circular turn in the level road. So we'll derive that expression. Before that, as I've explained in the previous slide, when a body moves in a circular path, that is a centripetal force is acting on the object. There is a change in the direction of the object at every point. There is change in the direction. That is due to the centripetal force which is acting on the object. There is change in the direction. That means there is a presence of centripetal acceleration. If you say there is a presence of centripetal force, only then the object can move in a circular path. What will give you that necessary centripetal force? In case of this derivation, for deriving a maximum velocity, that we'll see in this slide. In case of stone rotated in a circle, a tension in the string will provide you the necessary centripetal force. Similarly, artificial satellite moving around the earth, what the gravitational force of the earth will provide you the necessary centripetal force. Similarly, in this case, what will provide you the necessary centripetal force to keep the car, to help the car to take a circular turn? Consider you have a level road. A car is moving in a level road. It happens at certain point it has to take a circular turn. So what happens? A car is moving in the forward direction. So the direction of speed will change at each point of the car. If it is moving with certain speed, with the same speed it cannot take a circular turn. That might lead to the sudden accident. What you have to do? When the car is moving, it have to apply brake. You have to apply certain brake so that the certain amount of speed you can take a circular turn. So to apply brakes, if you apply brakes, with the speed will slow down. With a certain amount of required speed, you can safely take the turn. So when you apply brake, we have studied in the previous session, the brake will work with the principle of friction. When you apply brake, the centripetal force is along the surface. Acting along the surface. So you can see the tires of the car is in contact. It is in contact with the surface of the road. So that will give rise to a friction. The certain amount of friction will help you to give the centripetal acceleration, will give you the required centripetal acceleration. So if you measure in terms of amount, the large number of friction is provided. If large number of friction is given, then centripetal acceleration to keep the car in the circular motion will be more. So I can write friction should be greater than or equal to centripetal acceleration. So it will provide the centripetal acceleration. That means the required centripetal force. What is centripetal force? mv square by r. It will provide the necessary centripetal force for the circular motion of the car in the circular road, level circular road. For example, there are three components that are the three forces acting on the car. One is the normal force, which is acting in upward direction, and due to car has some weight, there is a downward pull acting in vertically downward, and there is a friction. As you apply force, as the car moves, there is a equal and opposite force acting, that is the friction. In this case, it is the static friction. that is Fs, opposes the motion of the car moving away from the circular path. It is the static friction. We know static friction, F, static friction, normally friction is mu s by n. Static friction is Fs is equal to mu s by n. What is mu s? Coefficient. What is mu s? Coefficient of static friction. Consider a level road. Consider a level road. A car is moving in the level road. It happens at certain point, it has to take, you can see here, at certain point it has to take a circular turn. It has to take a circular turn. When it has to take a circular turn, if it moves with the same speed, it's a constant speed without any variation, with that same speed, if it takes the turn, there is chances of getting accidents. So what happened? We apply a sudden brake when we get a turn in the level road. If we get a circular turn, we apply a brake so that the speed will slow down. We can take a safe turn. So when we apply brakes, brake work on the principle of friction. When we apply sudden brake, so you can see the tire, car tire is in contact with surface of the road. So friction will be developed. So if you see the amount of friction, if amount of friction is more, that will provide us the centripetal force. Centripetal force is given by mv square by r, mv square by r. So if centripetal force is provided by a friction which is developed due to the contact of tire and the surface of the road. So when centripetal force is developed, centripetal force is required for an object to keep in a circular orbit, to keep in a circular motion. We require centripetal force. That centripetal force here is provided by the friction, that is nothing but a static friction. Static friction is the friction which is opposing the motion of the car from moving away from the path of circular motion. So it is a static friction here. So you can write N is equal to mg, because when you talk about level circular road, it is the horizontal road we are talking about. It is the horizontal road. So there is no acceleration along the vertical component. There is no acceleration along the vertical component. So the normal reaction N will balance the weight of the car. So N is equal to mg. We are considering N is equal to mg. Along the horizontal road, it is a friction between the tire and the surface of the road which is giving us the centripetal force which is acting along the surface of the road. So what is centripetal force? Given by mv square by r, mv square by r. What is static friction? It is given as mu s by n. We have studied in the previous session of friction. Static friction is given by mu s n. Mu s is coefficient of static friction, that is greater than or equal to mv square by r. So there is no acceleration along the vertical direction. So we are only considering the horizontal road. So I can tell a normal reaction is balancing the weight of the car. So N is equal to mg. Substitute that here in place of m. So you have coefficient of static friction mg greater than equal to mv square by r, mv square by r. So here you can see static friction in place of normal reaction. I have substituted N is equal to mg greater than equal to mv square by r. M gets cancelled. So you have m static friction is equal to greater than equal to v square by r. I want what is the maximum safe speed for a car to take a circular turn. I want what is the maximum safe speed required for a car to take a circular turn. That is nothing but I need maximum velocity. So it is v max square less than or equal to, it will be msgr, msgr. So if you take out the square root, it will be mx less than or equal to square root of static friction g and r, g and r. So this is the maximum speed required for a maximum safe speed required by a car to take a safe turn. If the value of speed is greater than this value, then there is chances of car getting skid. The value of the speed must be less than equal to this value. If it is greater, then there is a chance of skidding of the vehicle. So this V will depend on the static friction mu and R, the radius R. It is independent of mass. This is the expression for maximum velocity for an automobile on a level circular road, So next we have banking of roads, where we have to derive expression for maximum velocity for an automobile on a circular banked road. It is not level circular road, now it is circular banked road. Then why we need this banking of road? Why? What is the necessity of banking of road? Because in the previous slide we have seen it is the friction which provides us the necessary centripetal force to keep the object in the circular motion. So if the amount of friction is more, then we'll get a proper required centripetal force. But we always cannot depend on the friction because it depends on the external factors. Friction depends on the external factors like frosting or rain, then we cannot always depend on the contribution of friction for the necessary centripetal force. So we come up with banking of roads. Then what do you mean by this banking of roads? The contribution of friction can be reduced by the banking of roads. In the previous line, here you can see the process of raising if you have a level road, the process of raising the outer edge over its inner edge by an angle theta, is called banking of roads. So when the outer edge of the road is raised over its inner edge by an angle theta, it will provide the vehicle necessary centripetal force. It will provide the vehicles or any heavy vehicles required proper necessary centripetal force to take a safe circular turn. So we can reduce the contribution of friction to provide a necessary centripetal force. So we have adopted banking of roads, where the process of raising the outer edge over its inner edge by an angle theta. This is the raised part. So this theta is called angle of banking. So we always cannot rely on the contribution of friction because friction depends on the external factors like rain, etc. So in order to reduce the contribution of friction, we come up with banking of roads, where the outer edge of road is raised over the inner edge by an angle theta. So you can see here, so it will provide the heavy vehicles, necessary centripetal force to take a safe circular turn. So here we have to derive an expression for maximum velocity for an automobile now, not in the level circular road but in a circular banked road. How will you derive the expression for maximum velocity in case of banked road here? Let us consider a car. It is moving in certain mass m and velocity v. A car of mass m is moving with a velocity v in a circular path. Now what happens is, we have four forces that are acting on the car now. What are the four forces? One is the normal reaction N, one is the friction force, that is nothing but the static friction force, Fs is equal to coefficient of static friction into normal reaction. So it is the static force acting on the car, and the third is the weight which is acting vertically downward, W is equal to mg, and fourth is the centripetal force, that is nothing but mv square, that is the centripetal force. Fc is equal to mv square by r, that is nothing but the centripetal force that is acting towards the center of the circular path, So what are the four forces that are acting on the car which is moving with mass m and velocity v? One is the normal reaction N, One is the friction force, that is a static friction force, and also a vertically downward force, that is weight W is equal to mg, and fourth one is the centripetal force, that is mv square by r, that is mv square by r. Fourth is the centripetal force mv square by r, which is acting towards the center of the circular path. So we have the four forces acting on the car, which is moving with mass m and velocity v in a circular motion. Now what I have to do? I have to consider the components. Now similar diagram is elaborated here in diagram B. It's similar, this is diagram A. So similar diagram is elaborated in B, where you can see the components of n vertically as well as horizontally. This is horizontal, this is vertical. What are the components of n in the vertical? It is n cos theta, and along horizontal it is n sin theta. What is the component of n in the vertical? It is n cos theta, and along horizontal it is n sin theta. Similarly, what are the component of force along vertical and horizontal? What are the components of force? So component of force is nothing but along vertical it is f sin theta, and along horizontal it is f cos theta. So we got to know there are four forces acting on the car. Now from this diagram you can see what are the components of n and what are the components of force along the vertical and horizontal axis. The components of n along the horizontal it is n sin theta, and along vertical it is n cos theta. What are the component of force? It is along the horizontal it is f cos theta, and along the vertical it is f sin theta. With this, the net force, what is the net force? The net force along vertical is equal to, so the net force along the vertical, when you can see when there is a banking of the road, the centripetal acceleration, the centripetal force, then there is banking of road, the centripetal force is given by the horizontal axis. The car is leaning towards the horizontal. So there is no net force along vertical. It is equal to 0. So you have, what are the components along the vertical? It is n cos theta is equal to mg plus f sin theta. When it is vertical is equal to 0, what are the components in the vertical? N cos theta is equal to mg plus f sin theta. So if I want mg, it will be mg is equal to n cos theta minus f sin theta. N cos theta minus f sin theta. Consider this as your first equation. So the vertical axis, the car is leaning towards the vertical. It's leaning towards the vertical in the banking of roads. So the horizontal axis will give you the necessary centripetal acceleration. Fc is equal to centripetal force. Fc is equal to mv square by r. So you have second equation along the horizontal. It is the centripetal force is given by mv square by r. So you have mv square by r is equal to, what are the horizontal components? Vertical it is n cos theta, f sin theta, mg. Along the horizontal, you can see the road is banked by an angle theta. So the horizontal axis will provide you the necessary centripetal force. So centripetal force is given by horizontal components, that is n sin theta plus f cos theta. This is your second equation. And we know F is equal to, the static friction is equal to mu s n, coefficient of static friction into normal reaction. So divide equation 2 by equation 1. So we have mv square by mg is equal to, divide the equation 2 by 1, n sin theta plus f cos theta divided by the first equation, that is n cos theta minus f sin theta. So substitute what is the value of f. Static friction is equal to mu s n, and here you can see you have r here, mv square r, m and m get cancelled. So you have v square rg is equal to, substitute mu Sn in place of F. So you have n sin theta plus mu Sn cos theta divided by n cos theta minus, so what is the value of F? Substitute mu Sn sin theta. Mu Sn sin theta. Now what happens? You have n common, take out the n and divide the each sin theta, cos theta by cos theta. Divide these by cos theta, take out n which is common in all the terms. So you'll get n is equal to sin theta, I'm dividing by cos theta, all the terms by cos theta, plus mu s, n is taken out common, cos theta by cos theta divided by, n is taken common, cos theta by cos theta minus mu s sin theta by cos theta. So cos theta by cos theta, it is nothing but equal to 1. Then what is sin theta by cos theta? It is tan theta. So what you'll get? Tan theta plus mu s. So you'll get tan theta plus mu s, tan theta plus mu s divided by 1 minus, this is cos theta by cos theta, it is 1. So 1 minus mu s, it is 1 minus mu s. So you have n outside is equal to, what is equal to? V square by Rg. It is equal to V square by Rg. I want what is maximum velocity. So V max is equal to, shift the term, so you'll get Rg. So here you can see n and n, it is there common in both. So here you have n and n common in both. So you have n and n common in both. It gets cancelled out. So you have V max is equal to Rg. V max is equal to Rg. What is this? Square root is shifted and it is equal to tan theta plus mu s by 1 minus mu s. So this is the equation for V max, maximum velocity in a circular banked road. For a smooth road, if you want a smooth road, then your static coefficient of static friction will be equal to 0. If that is equal to 0, this will be equal to 0. So here you can see it is n cos theta is 1, 1 minus mu sin theta by cos theta. You have tan theta here, you have tan theta here, you have tan theta here. So you'll get, if mu s is equal to 0 for smooth surface, if you want smooth curve, then mu s is equal to 0, then you'll get V max is equal to square root of Rg. Rg, it is 0, then it will get only Rg tan theta. Rg tan theta. So this is the equation for V max. So maximum speed, that is the maximum safe speed required for any vehicle to take a safe circular turn. To take a safe circular turn, V max, maximum velocity is equal to Rg tan theta if mu is equal to 0. For this is for a smooth curve, smooth surface, mu is equal to 0. So what is banked road? What do you mean by banking of road? The outer process of raising the outer edge, the process of raising the outer edge over its inner edge by an angle theta. Theta is the banking angle. So that will provide the heavy vehicles the necessary centripetal force to take a safe circular turn. That's why we always cannot rely on the friction to provide the centripetal force, necessary centripetal force. In order to reduce the contribution of friction, we have used banking of roads, where I have derived the expression for maximum velocity for a banked circular banked road, where you can see the car is raised, outer edge is raised to over its inner edge by an angle theta. The car is moving with mass m and velocity v in a circular motion. So there are 4 forces acting on car. One is the normal reaction, which is acting upward. Equal and opposite to normal reaction, there is a downward force, W is equal to mg, and there is a friction acting, that is static friction, and also there is a centripetal force. Due to banking of road, there is a necessary centripetal force provided which is acting towards the center of the path, that is mv square by r. So next, what are the components of n along the vertical and horizontal axis? Along the vertical it is n cos theta. The component of n along horizontal it is n sin theta. What is the component of force F? Along vertical it is F sin theta. Along horizontal it is F cos theta. So we know the centripetal force is provided by the horizontal axis because the car is falling towards the horizontal axis. So there is no net force along vertical. So you can write n cos theta is equal to F sin theta mg, from which I get mg is equal to n cos theta minus F sin theta. That is equation 1. Next I have the necessary centripetal force is provided by the horizontal axis where the car is moving, leaning towards the horizontal axis. This horizontal axis will provide you this horizontal axis, that is n sin theta and F cos theta is providing necessary centripetal force mv square by r. That is your equation 2. So we know static friction is equal to mu Sn, F is equal to mu n, coefficient of friction, that is coefficient of static friction. Substitute, divide 2 by equation 1. So you get this. So substitute, take the n which is common in both and substitute the value of F, that is mu S n. Your m and m get cancels when these two equations are divided and you have this format where your n and n is common in both, it's taken out and you have sin theta. I've divided each term by cos theta and substituted the value of F. Cos theta by cos theta is nothing but 1, sin by cos is nothing but tan. So you have n and n gets cancelled here, n and n gets cancelled which is common in both. So sin theta by cos theta is tan theta plus mu s into 1, mu s divided by 1 minus cos theta by cos theta is 1, 1 minus mu s sin theta by cos theta is tan theta. So you have, when square root is shifted to RHS, RG is shifted here, n and n is cancelled, you have tan theta plus mu s by 1 minus mu s tan theta. So for a smooth surface, mu s is equal to 0. You will get this as the maximum equation of velocity to take a safe turn in the smooth road. So that's all for today's session. We discussed what is centripetal force, a force required to keep the object in the circular motion. It is acting towards the center of the circle. And what is the equation for centripetal force? It is mv square by r. And we studied what is centrifugal force. What is centrifugal force? It is the force that pushes the object away from the axis or center of axis of rotation or center. So that is centrifugal force mv square by r. So next we studied the banking of roads where we derived the expression for velocity in the level circular road and in the circular banked road. So in the level circular road, the friction will provide you the necessary centripetal force. The friction between the tires and the surface of the road will provide you the necessary centripetal force which is acting along the surface. So always we cannot rely on the friction because it depends on external factors like rain, etc. So in order to reduce the contribution of friction, we use banking of roads banking of roads. What is banking of roads? The outer edge is raised over the inner edge by an angle theta. Theta is angle of banking. It is raised by angle theta. So that will provide the necessary centripetal force for heavy vehicles to take a safe turn in the circular path. And we derived what is the velocity equation for maximum safe speed of a car in the circular smooth road. We know it is V max is equal to root of Rg tan theta for a smooth surface, So we use banking of road in order to reduce the contribution of friction. That's all for today's session. Next, I'll come up with a new chapter and new interesting session where we'll study what do you mean by work, energy and power. Until then, go through all my sessions of laws of motion. Until then, take care. Have a good day. Thank you.